Let's talk about atoms. Greek philosophers first talked about atoms as the smallest individual particles of a material that would have the properties of that material. But the Greeks didn't do science. What they did was rhetoric. They debated things, and the guy who made the best argument won. In a lot of cases, that guy was named Aristotle. And it's really too bad because Aristotle was the poorest of the Greek scientists, and the ideas that he put forward are almost universally incorrect. The first thing to be discovered, actually, was one of the components of atoms. The electron was discovered in the late 19th century. Turns out to be pretty easy to make electrons. All you have to do is seal a metal wire into a glass tube, pump the air out of the tube, and heat the wire. And electrons will just boil off of it into the space around it. And if you put a positively charged electrode in the same glass tube, the electrons will be attracted from the hot metal wire to the positively charged electrode. And this gives rise to a flow of electrons in the tube and a primitive electron ray tube, the predecessor of something like a television set or an X-ray generator. The electrons turned out to be extremely lightweight, but having a pretty powerful electric charge for their weight. Years earlier, people thought there were two kinds of electricity in the universe. There was resinous electricity, which you got by polishing a piece of a resin like amber with a cloth. And there was vitreous electricity, which you got by polishing a piece of glass with a cloth. It was our own founding father, Benjamin Franklin, who recognized that these were really the same kind of electricity. In the case of one of them, it was a surplus of charge carriers, and in the case of the other, it was a deficiency of charge carriers, and when you connected these two together, you'd get a spark as the surplus jumped over to make up the deficiency. Now, unfortunately, Benjamin Franklin thought that the charge carriers had a positive charge, and that's why to this day electrical engineers talk about current flowing from positive to negative, but physicists know that electrons flow from negative to positive. In any case, electrons are fundamental particles. As far as anyone has ever been able to determine, they cannot be broken down into anything smaller. In fact, they're so small that it's really not possible to measure their size with existing equipment. As far as theoreticians are concerned, an electron is a point particle. It's like a mathematical point. It has so little extent. But it does have mass, and it does have electrical charge, and it has a third property, which we call spin. It's hard to think of something with no size actually spinning, but the electron has a magnetic moment, such as it would have if it were a spinning negative charge. The earliest scientific models of the atom placed electrons in a kind of a sea of positive charge. This was called the plum pudding model, with the electrons being the plums and the positive charge in the atom being the pudding, which holds them together and keeps them apart. It was not until the work of Ernest Rutherford that this plum pudding model was challenged. What Rutherford did was to send little positively charged bullets, like alpha particles, helium nuclei, into atoms of gold, which were in a very thin gold foil. You can make gold foils so thin that light will pass through them. And it was in one of these thin gold foils, bombarded with alpha particles, that Rutherford's assistants, including a fellow named Hans Geiger, who later went on to invent the Geiger counter, Rutherford's assistants observed that most of the alpha particles went right through the gold foil as though it was empty space. But a few came right back at the source of the alpha particles. Now, that was unexpected. And that's what led Rutherford to speculate that most of an atom is in fact empty space, but there are some very heavy positively charged particles in the atom. And he took a page from the biologists who had called the central organelle in a cell the nucleus, and he called this the nucleus of the atom. So by the beginning of the 20th century, this was the nuclear model of the atom, which had evolved from the researches on electrons and on the reflection of alpha particles from gold nuclei.